All right. Well, good afternoon. Welcome to the North Carolina AgTech Professional Forum. I'm Michelle Von Cannon, the Agricultural Program and Event Manager here at the Biotech Center, and we're so glad you're here to join us for the last forum of 2022. A few housekeeping notes. Andy will be sharing how we're going to be doing Q&A this in a few minutes about this panel so pay attention to that. And this program is being recorded and will be posted on our event website next week. So in case you want to share this program with some colleagues or come back to something very important that was said, just know it'll be on there next week on this specific event page. I have a few upcoming events to share. We are at the end of the calendar year, but as many of you know, we had to reschedule our September forum that was going to be on animal health and nutrition and its correlation with One Health. We have moved that to February 15th. It will be here at the Biotech Center again in person. It'll be moderated by Sid Thacker, who is over at the, I always say that wrong, the Center for Veterinary Medicine at NC State, who is heading up a program on One Health. So it's going to be really compelling. So we hope you can attend. That information is up and registration will open next week. Then we have the February 16th. So as many of you are aware, we had the Women in Agribusiness group that was coming to town before COVID, and we're excited to welcome them back in 2023. They lead an Ag Club lunch, and we will be hosting it in Raleigh on the 16th at lunchtime. And then that evening, we will also be having a happy hour. Both locations are being finalized, so we will have that up online shortly. So, and you don't have to be a woman to attend. You just have to be a female supporter. What was that grumbling? I'm kidding. All right. I also want to take the time to welcome our sponsors. Without our partners in the AgTech community, we would not be able to provide programs like this. So I'd like to thank our supporting sponsors, Myers-Beagle, Smith Anderson, and our patron sponsor, which is Alexandria Scent Labs. And our lead sponsor for today is Hughes Pittman Gupton. Unfortunately, Rod Wilson, who many of you know from Hughes Pittman Gupton, and his team were unable to attend today due to a last-minute conflict, but they are a proud sponsor of the forum series, and they are sad they are not here. Hughes Pittman Gupton is a locally owned and operated full-service accounting firm based here in Raleigh. Rod is a partner at HPG and leads the firm's Ag Bio practice, which is a subset of the firm's broader life sciences package. He also leads the firm's outsourced accounting services, which provide accounting services on an outsourced basis, ranging from day-to-day transactions to fractional CFO services, and additionally, traditional tax and audit services. So we're sorry they're not here today, but food, beer, and wine are all on them. So stay tuned afterwards. So at this time, I'm going to introduce today's moderator, Andy Curliss. Many of us in the AgTech community have known Andy for a long time. He was the former CEO of the North Carolina Pork Council and has been very active in this community for a long time. Currently, he's now the National Director of Strategic Initiatives over at SAS Institute, where he works with company leadership on strategic planning and with customers in the government, commercial, and nonprofit sectors. He is currently serving on multiple boards, including ones and commissions at NC State and North Carolina A&T State University. And before these roles, he did start out as a journalist, including serving as a state government editor and a longtime investigative reporter at the News and Observer of Raleigh. So I'd like to welcome Andy.
Did you hear how she said journalist? And it was kind of like a journal. I was not fake news, just so you, I was real news back then. So it's good to be with you. I'd invite the panel to please come forward and take your seats, and I will introduce them. So let's go ahead and get situated, and then once we're in place, I will let everybody know who we're going to hear from. And given we have a distinguished panel, And so the introductions with the bios is probably going to take about an hour. I just want to warn you. And then we'll have time for one question. No, I'm going to shorten this. So let's start all the way on the end. Wes Ward is Senior Vice President at Harvey's, the 150-year-old agricultural products and services company that was founded here in North Carolina. Many of you may know it's in Kinston. In that role, Wes leads all Harvey divisions, including an ag retail division with 16 stores, 8 propane locations, a 7,000-acre farming operation, 2 cotton gins, a seed conditioning facility, which packages soybeans and wheat for Syngenta, USG, Winfield, and Harvey Seed Line, and others. He was raised in Conway, where his family owned a cotton gin for 20 years and a grain elevator for 50. And he graduated from NC State University with a bachelor's in ag business and a minor in economics. Next to him is Dr. Goins, Gregory Goins, professor and chair of the Department of Natural Resources and Environmental Design at North Carolina A&T State University. Aggies do. He is also currently serving as the interim associate dean for research in the College of Agriculture and Environmental Sciences at A&T. During his tenure as an educator at A&T, he has focused on broadening participation in STEM careers. He was recognized by the White House as a champion of change for HBCUs, has served as an NSF program director in the Division of Undergraduate Education, received a bachelor's in biology from UNC Chapel Hill, and then got smarter, right? Because a master's and Ph.D. in crop science at North Carolina State University. Next to him, sorry about that, I just couldn't resist. Next to him, Dr. Kranos Williams is the Goodnight Distinguished Professor of Agricultural Analytics at North Carolina State University, with primary and secondary appointments in the electrical and computer engineering and plant and microbial biology departments. And Dr. Williams also serves as the platform director of the data-driven plant sciences research platform of the North Carolina Plant Sciences Initiative and is the head of the Embiosis Research Laboratory. There's a whole bunch of other stuff, Dr. Williams. I'm going to skip to just say he's highly accomplished and received his BS in electrical engineering from North Carolina A&T State University, and then a master's and a PhD in electrical engineering from North Carolina State University. Dr. Williams. And then lastly, closest to me, Dr. John Cutula, Director of Crop Science at SAS. At SAS, he consults with some of the most prominent AI digital projects in the ag industry. He was awarded a U.S. patent earlier this year for an analytics method to increase discovery pipeline hit rates and lab to field translation. He's previously worked in seed and agrochemical research in both the development and regulatory arenas. But he likes to say that he learned statistics on the job while working in industry. It's originally from Nebraska, maintains a family orchard there to this day, and received a bachelor's degree from Texas Tech University and a PhD in plant pathology from Cornell. So welcome our panel. The advance one slide. Look at that, it looks real nice.
Cooler.
Does anybody need a water too? While
I'm
we're
good. Yeah.
gonna pass one down? John, you good?
We got work.
All right, I'm gonna take one if that's okay. So the panel is data science and ag, and I wanted to start with a basic question. We'll run down through, maybe start here with John and then come back on the next question. But really it's, that's a big topic, data science and ag. And so I wanted to start with just what does that mean? It means a lot of things to a lot of different people. So as we start the discussion, data science and ag, what does it mean to you? How do you define that? And let's start here with John, work our way down.
Yeah, sure. I was giving a talk at the Controlled Environment Agriculture East Summit a couple of weeks ago. And it was a room of 250 people and all eyes on me. And I found that after COVID, you really have to engage the audience to maintain attention. And so I started off by asking, the audience, who here works with data? And only about a quarter of the hands went up at a controlled environment agriculture summit. And I said, this is like the least data-driven audience in agriculture that there is. Most people, and myself included, we started out working with data on spreadsheets and Excel. And honestly, that's where most of the data science is done to this day. And so whether you work in breeding or agrochemical development or precision agriculture or animal agriculture or a farming practitioner, chances are you work with data and data is somehow core to your business. And so data science is just a way to analyze that data and use that data at scale. At least that's my view. I'd love to hear Dr. Williams and the other panelists.
Thank you, John. I mean, for me, when I think of data science in ag, I think of the process of going from data to knowledge, knowledge to decision-making, or knowledge to information. And for me, I think that there's a pathway of things that need to be done in order to actually accomplish that. And it really goes from the ability to efficiently acquire information, especially at scale, because there's tremendous amount of information, tremendous variety in how this information is structured. And there's a need for us to not forget that that is an essential part to leveraging data science. And then once you have it, you have to be able to organize it in an effective way. If you cannot organize it, it's going to be extremely difficult to use it. So identifying meaningful ways of structuring heterogeneous data in ag becomes extremely important. And then the last thing that is essential to be able to transform data to knowledge and information is the analysis. So how do you incorporate the types of analyses that are necessary to do that, especially with the complexity of the data that we have in the ag sectors, becomes important. So when I think of data science in ag, I think of the need to be able to advance these core areas to really be able to transform data to information.
Excellent. Dr. Goins.
How do I follow that? That was great. Both of you, appreciate it. And thank you for inviting Andy and your colleagues. Come back to A&T again. You were there the other day, John, and everyone else, and Michelle, thank you. And I put some ag research magazines out there. I can get some more if you picked up one, where we're concentrating on climate change. And that's just it. Farming, my friends, I'm a third generation farmer, I operate a small farm in Guilford County. Farming is a business. Okay, if you disagree with me, that's fine. But if you want to, farm for over a long time, it is a business. And it involves a lot of risk. And doing those things, like Carano said, is if you're able to predict, able just to be able to look a little bit beyond the guy that defeated Napoleon. They said he could, who was that, Duke of Ellington? He could predict what was on the other side of the mountain. And that's huge for farmers. Farmers are actually willing to take a hit on yield if they know exactly what they're going to get at the end of the season. So using all the powers of data science, I think that's the beauty of it, is it's going to allow our farmers to better look on the other side of that mountain. But at the same time, though, there's a lot of equity issues where the language, because between the different disciplines, a chemist will say, the rate of reaction, a biologist say carrying capacity, a mathematician will say ODE equals 0, so there's a lot of things that we need to do and people in this room to help translate the data of the data science. Thanks.
Yeah, so I think data science is what a huge umbrella in agriculture. So I think depending on what profession you are, is that the ag retailer, is that the chemist, is that the manufacturer, or the farmer? So I'm going to answer the question specifically like I'm a farmer, because I think that's the root of, is data science and agriculture going to be successful? So, as a farmer, first thing I think about in the beginning of the year is my marketing plan. I'm looking at commodity prices, looking at data points, historical charts of how commodity markets are moving throughout the year to base how many acres of any given crop I'm going to plant. Then I move through the year and I say, well, how much lime or fertilizer am I going to, put out? And that's all basis the soil sample that was taken in the soil. What did my indexes look like on, say, potash, and then run it through an algorithm to know how much potash I'm going to put out on any given acre. And then when I get into the spring and I go to plant my seed corn, am I going to use 35,000 population on corn or 38,000? I'm going to base that decision off of data. Is that field 100-acre field, 70 acres under irrigation, 30 acres not under irrigation? Some's more productive, some's less productive. And I'm basing that off of algorithms and how productive some of the soil is. Then when I go and pick the crop, I'm looking at yield maps and I'm looking at data analytics from that side of things, which is really forming a lot of production decisions going into the next year. So I think data science and ag is so broad, and you almost have to answer it specifically basis your industry that you're in ag. So.
Oh, yeah, that's good. I don't want to name names. There was a political candidate a couple of years ago that said it was just dig a hole, put the seed in the ground and put some water on it. It doesn't sound like that's what you're doing. So that's good. Yeah. So let's stay with that and let's come back down this way. So I want you to think about that value chain. You talked about the umbrella. So we can say farm to fork, or what are some of these other rhyming? Dirt to shirt, I've heard lately. Plant to plate. We need one more. We need 4. But okay, but think about the whole value chain. And I wonder if you might just tell us something that is happening where data science is really making a difference right now. You know, the topic of the panel is foundations and frontiers. Those foundations are in place, they're being used. Give us a sense of something specific that where it's making a difference.
Sure. So, to me, the biggest thing that I see is lower input cost. Because if we can better analyze data, I think, Gregory, you mentioned it, that some of these growers will settle for lesser yield just because they can reduce their costs, right? So the ROI may go up or at least stay flat. So I think the biggest thing in analytics and agriculture today is, can I use less of an inputs on my farming operation and maybe enhance my ROI or stay flat? And as we decrease some of our inputs, maybe we're more sustainable if we're putting out too much phosphorus close to our watershed. So I think today that's making a big impact.
Efficiency. Dr. Goins?
Yeah, and we passed the golden era of glyphosate. And so we're going to have some algorithm, something, figure how deep to plant that seed. It depends on the soil. And for, this is North Carolina, right? I got something I got to tell you. North Carolina soils are poor, generally, okay? So you need that data to be able to, how are you going to ameliorate the soil to grow whatever you're doing. Tobacco, we wanted the soil to be poor because you get the nitrogen out of it. But at the end of the day, if you grow some other crops, you need to know some of those things that you need to do to make up that difference. So one of the examples is the new dwarf corn that is being tested right now. I think that's a good example, because guess what, folks? No one's ever increased the rate of photosynthesis. It takes 8 moles of carbon or something like that. Check me out, my physiology. You know how you increase yield? The competition, the planting rate, or kill the weed. That's the way you increase yield. No one is going to change how much right now. Maybe we will. That'd be great. The micromoles of light come in. How does that get converted into carbohydrate from water and CO2? That process is all the same. So therefore, the competition is the key, and data science is a good way to be able to predict and get past some of those yield decreasers.
Yeah, Dr. Williams, data science making a difference right now.
What I would say, and I'm speaking as someone with a initial expertise in a non-ag area that knows enough biology and ag to be dangerous to myself and others. And I think where some of this is actually making a difference is the incorporation of some of these other disciplines to really leverage and develop algorithms that can effectively understand the complexity of not only the data that we're dealing with, but the problems that we're dealing with. And the idea that you can expose this level of information, this level of contextual knowledge to individuals that are outside of the ag realm, but possess a tremendous amount of knowledge in terms of the types of algorithms that can be developed, whether it's machine learning, whether it's AI, whether it's complex analyses, and have them have not only an appreciation for the problem, but use that appreciation to develop algorithms that can generate novel solutions. And I think that's happening today. That's occurring now in terms of workforce development for companies like SAS and other biotech companies, where you're exposing students to this type of knowledge. It's happening now in terms of the research and the interdisciplinary training of graduate students to be able to have that fundamental knowledge. And ultimately, I think that that's going to make a transformative difference, especially in the coming years, in terms of how we are able to address these specific complex problems.
Yeah, I agree with everything that's been said. And I think one of the sort of common themes is in product development and creating inputs, whether seed or agrochemical inputs, and being able to more effectively create new inputs and lower input costs. I see on the horizon and in the years that I've been in ag, essentially an AI dry spell. There are very few insecticides, if any new insecticides that have come out in the past decade. Very few new herbicide modes of action. Very few new fungicide modes of action. Though that's changing, and a lot of people are working on novel chemistries and microbes to change that. I think one of the things that we have to get used to as we're working with software chemistry in developing software chemistry is becoming more able to use products of lower efficacy than what we were used to. But oftentimes, and I went to the American Society of Agronomy conference last week, I saw a lot of presentations where people are still using statistics that came into prominence in the Green Revolution, right? Have you guys seen those bar charts where it's like, all right, the control is A, and then each successive bar in a rate study or different treatments, it's A, B, A, B, A, B, A, B, A, B, right? And to me, that's not a product development problem, and the poor speaker has to expound on the trend and make these make these logical leaps. Well, it's not a problem with the biology. It's not a problem with the data necessarily or what the speaker observed, but instead that's a problem with statistics and the use of statistics to develop new products. So that's where these interdisciplinary means of data science come in, and we're bringing back to agriculture, being able to use different statistical parameterizations and machine learning and AI to improve product development, and hopefully and with some really good biology and disciplines of biology in hand to improve product development pipelines.
Well, why don't we stay on that, because you're sort of alluding to what's ahead, what's next, what's out on the horizon, and I wonder if we might just go with that for a little bit. And so we talked about foundations. Let's go ahead and talk about frontiers. Look out 3-5 years. What do you see kind of the next? If we're in this desert, so to speak, in the areas you talked about,
Sure.
Where do you see the frontier with actual accomplishment, not pie in the sky?
Yeah, I would just be cautious, and that there's a whole lot of bluster in the discussions of data science and ag, and it turns out once you go back and read those old press releases from 2018 and 2015 and 2012, actually very few of those pie in the sky predictions have actually panned out. Billions of dollars have been wasted in companies and company acquisitions that never made a product. Billions of dollars have been wasted in cloud and cloud storage costs. Why is that? It's not that that it wasn't founded on a good premise, or that the algorithms weren't right for the situation necessarily. What the analysts have found, and the people who study this stuff, is that it's actually due to a lack of connection and cohesion between subject matter experts and data scientists. So often in industry, how it works is you have subject matter experts that collect data, scientists who do laboratory experiments or field trials or work with customers, and then they package up the data and throw it over the wall to a data science team in the hopes that the perfect answer will come back. That's actually not how it works. And so the trend in data science, and it's coming to ag, is called multimodal analytics, getting people working together, subject matter experts, data scientists, data engineers, to tackle a common problem. That's an innovation, and I think that's what's going to foster real innovations to come.
Dr. Williams, frontiers.
Yeah, I mean, I have to wholeheartedly agree with John's comment. I think the frontier is going to be making those interactions between those subject matter experts and your data scientists more actionable. And the question is, how do you do that? And I think to some extent, it's going to be ensuring that these individuals are focusing on translational types of implementations for the data that's being generated. And this means having cohesive and coherent teams. This means having everyone involved in the problem definition, having an appreciation of the problem itself, and looking at developing solutions based on an understanding of the problem, as opposed to just what can be done with the data. And I think that honestly, this leads to the potential of additional frontiers of analytics that are going to be specific for the data that's generated. Not just general analytics for analytics' sake, but the development of novel areas of machine learning, AI, data analytics that are going to be tailored to the types of problems that are being generated. And I think that that honestly goes across the board. And if we have the ability to do this across the value chain, I think that's where the frontier is going to be, as opposed to, again, just taking rows and columns of information and sticking it through an algorithm. You're going to have something that's more tailored to the types of problems that we have. And that's where I think the frontier, the next frontier is going to be.
Interesting. Dr. Goins?
That's a great comment, both of you. In agriculture, there's a lot of hidden dimensions. And those hidden dimensions, again, lower the risk for growers. But we as a nation, if you talk about the United States and really the world is becoming more meat eating. So ultimately that means more water, So that's, I think the next frontier is looking at the energy, and water is energy, you got to pump the water where it ain't. So, but there's a lot of political connections in the water resources. Like below San Diego, they get the water from the Ogala Aquifer, which, but that's hard baked into our legislature laws, from the 1800s. So data science is going to have to be, and making sense of it, is going to be a key factor to be able to, as they say, translate to where the politician and all stakeholders in this process, as we try to feed the world, the 2050 scary numbers, the data science is going to have to be key to make a convincing argument to those people who are routinely protected by the hidden dimensions of our system. Thanks.
Dr. Goins, so you're saying politicians will make decisions based on facts and data at some point? That is a frontier.
At the local level.
That's a
I shouldn't say it.
I'm just kidding. Wes.
County commissioner.
Frontiers.
So I would say the frontiers in agriculture when it comes to data is that, we look at certain analyses and algorithms and we want to apply it to the foundation of farmers, but there's no year like it was in 2022 versus 23 and in the future from a weather perspective. So when we go back and we look at something, we say this had to increase 9 bushels per acre for my soybean crop because that's what the data says it should. I think the biggest thing in data science is that there's a lot of different facets of farming. They farm a certain way in the Midwest, a certain way in the Southeast, a certain way on the West Coast. So if you take whatever you perceive would be factual and you try to apply it to certain parts of the country and you're not sure the production practices or the soil types, et cetera, you can really throw your data out the window. So I think one thing to think about is, trying to get a big enough data set to apply it to common ground, common soil types, et cetera. And then I think another good frontier is going to be artificial intelligence. I think it's not a secret that labor is an issue in whatever ag sector that you're working in. So the more artificial intelligence that we can have to eliminate some of these labor issues and therefore decrease costs for a grower would be fantastic.
Good point. Well, and take one pause. You may start to have questions in your own mind. And I want to invite you, if you do have questions, I asked Michelle to have some note cards. You can raise your hand or you can come down and grab one. Put your question down and then I'll get it and I'll introduce it into the conversation. So we don't have to wait till the end and maybe you have a thought or two. So feel free to come down at some point and get a card. There's pens and we can take questions live and in the middle of the panel, and keep it interactive that way. So please feel free to contribute. All right, let's dig in on some topics, some more topical questions. And I'd like to start down with you, Wes, if that's all right. And really, this is in the area of challenges and hurdles. You know, we've heard a lot about things going on, things that could happen, but certainly we all know about some gaps. And I wonder if you might just share with us what you see from your vantage point as some of the hurdles to really the implementation and the use of data science and ag.
Sure. So I think the biggest barrier to entry for a lot of farmers, I'll go back to that perspective, is cost. The cost you've got to pay to play when you want to analyze data on your farming operation. You'd be surprised that a lot of guys don't have yield monitors in their combine. So how are they analyzing yield? They fill up a tender trailer, take it to the grain elevator. They divide the bushels by the acres, right? Which seems far-fetched in a room in an audience like this, that we don't have yield monitors and things like that. If you wanted to have a variable rate seeding plan for your farm, you have to have the planner to do that. That's $150,000. A lot of these growers can't afford that on some of these family farms. Then, of course, the next biggest thing is data accuracy. Guys who can pay to play, they'll spend a fair amount of money to get it up and going on their farming operation. They want to analyze how their corn hybrids did the next year. We go and look at what they planted. They planted corn hybrid 1, corn hybrid 2, corn hybrid 3, and corn hybrid 4. They didn't actually put the data in. So bad data in is bad data out, of course. Data sharing is something that I believe we may touch on later on. A lot of growers are territorial, because if Gregory here is picking high yields and he shares data or back and forth, then the land rent goes up. So nobody wants to share ideas. So data sharing becomes a problem as well. And then lastly, I'll say the technology itself. We were planting wheat yesterday on Harvey Farms, and we had to sit still for about 6 hours. And why was that? Well, the RTK tower, which provides guidance to make sure you're going in a straight AB line, as they call it, we were waiting on the software update for about 3 hours. So what did the guy do? He just kept planting. He didn't worry about it. Well, as we try to analyze data and so forth, we didn't have any data because he didn't process it through the system. So that's what I would say.
Yeah. And so, what was the question again? The barriers.
Hurdles, challenges.
Well, you know, I'm a North Carolinian. I know I have a New York accent, but I'm a North Carolinian. The jobs around this, it's just not the farmers. We're talking about the farmers. You could probably put them all in this room in a certain county, you know, as farms get larger. But that feeds into their communities and the whole economic ecosystem. So a lot of the support systems will have to require educations beyond the post-secondary level. But yet, what, about 40% of North Carolinians or something do not have that degree. So who is going to be the one that analyze the data and to live in those communities and be part of their economic system? We all know the issues with Eastern North Carolina. So that's one of the hurdles I worry about. And then along with that, you know, if Goins is collecting data, and I'm telling you, you need to collect data, how do I know that this person is not with the IRS? You know, so it's like trust. And I can say, I wouldn't brag on North Carolina A&T. That's one of the things that we have to overcome that hurdle of trust, is that we're in HBCU, we concentrate on the small farmers. We're not trying to, you know, push up into NC State space, although we work well together, Adrian. So one of the things we have is trust, and that can be a huge hurdle as you're trying to implement data collection and data science. Thanks.
Dr. Williams, hurdles, challenges?
I think one of the hurdles, and thus kind of transitioning to the potential opportunities, is the development of, and I'm going to put air quotes, technologies that are adaptable and to some extent scale-free. And what I mean by scale-free is it has the ability to lower the barrier of entry for implementation, not only for large farms, but also for smaller farms as well. And I think that there's a potential opportunity to really start to focus on those types of projects and look at the development of technologies that have the ability to do that. So whether you need $150,000 piece of equipment to measure yield, or whether you can use a $752,000 imaging system that could be strategically placed in specific parts of your production line, and an open source algorithm that may not give you those exact numbers, but will give you something that assists in the decision-making process. And I think it's those types of technologies that we have the ability to put in place, especially as you start to move forward with these types of interdisciplinary interactions. And I think it's those type of things that we have the ability to try to put into the hands of those types of growers and producers. But right now, without exposure, without a connection to those types of problems between the solution, the people who can generate the solutions, and where the problems are, it's going to be a gap. But I think it's a clear opportunity. I think that there's a space there to operate. And I think that that's really where things are going to lie as we move forward.
John, did you want to chime in on that one?
Yeah, of course. Yeah, there are plenty of hurdles, and mostly who I work with on a day-to-day basis are sort of the large enterprise ag companies, big companies, basic manufacturers, others. And the three things that I hear from them on a daily basis that are challenges are data quality, right? All data is messy in its own way. And it's very hard to create a repeatable data engineering framework across different data sets. And it's not only in agriculture, right? I mean, we think that every problem is unique to us, but in fact, 80% of data science projects are the data engineering portions. And so data engineering is absolutely a major hurdle to implementation. But oftentimes, people who get good at data engineering and groups that get good at data engineering actually tend to overdo it a little bit. They tend to create a knowledge information management project, an ecosystem, and keep investing on, all right, let's get the data right, and then we'll move on to analytics, and then we're going to profit, right? But it doesn't actually work that way, because you learn what data you need as you go along and as you probe it and as you ask the questions. And so, which brings me to problem number 2, which is the ability to ask the right question and the ability to frame the question in a way that data can answer it. And that ties into number 3, which we've all hit on, which is the skills gap. Being able to bring in subject matter experts in the fold in a very rich way in a daily collaborative system to be able to participate meaningfully on projects dealing with data science.
That's interesting. And I didn't hear the word broadband yet. And I also haven't heard the word drone. So we're doing pretty good. That was a joke. All right, let's keep going. We have 2 of our great land grant universities represented here. And so I wanted to give both Dr. Goins, Dr. Williams a chance to share with us a little bit about what's going on in your space at the universities. And we know that a lot of what happens at the universities both is taught and then carried out into industry that way. But you're also would be attracting investment, government funding coming in, industry partnerships coming in. And so I wonder if you might share with us a little bit about what's going on in your space, because for those of us who aren't in your space, it ends up being a little window into maybe a trend, maybe what's coming up next. And I'll start with you, Dr. Goins.
Okay. In the North Carolina A&T is 1890, the second Morrill Act, whereas NC State is 1862. And so our mission, although similar on the 3 pillars of land grant, extension, research, and teaching, so our extension base is somewhat different in terms of our charge is to work with people who were slaves, who are coming out of slavery, but yet they necessarily were not landowners. And so we work with that underserved, socially disadvantaged audience. And I really enjoyed that, being a small landowner myself. So we're always looking at value added Because if you're a small grower, you have to charge a premium in order to stay in business. So you can't just, you can't compete with Walmart or Food Lion. So we're always doing things, whether if it's out of season or season extension on high tunnels. Now the climate change issue it impacts minorities the most. So we're very keen on that. And if you pick up that magazine out there, and I'll bring some more art, you'll see that that's the focus of that magazine with Dr. Bowman looking at soil health and carbon. That's key. So that's a big area that we're looking at. And also we're looking at the health of the people, our constituency, our stakeholders, as far as what they're ingesting because of the food deserts and the highly processed food that you can, there's an issue with health. So that's all tied to agriculture. But at the same time, I'm happy to report that we have the Plant Science Institute, we have Kranos, who's a alumnus. So we're really tying this together. We're working together as one big family. And now I will say this about extension. Do I have anybody from Cooperative Extension in the room? Okay, very good, thank you. And you know this very, very well. The network of actors, as far as that translates what's happening in research, has changed. Used to, the researcher would give it to the extension agent would go out in the field. But now, because of broadband and other issues, now the extension agent could get bypassed or not even have to develop a relationship with my friend back there. So we gotta bring that back together where research and extension are one again. So that's kind of the issues that we're looking at.
Mm-hmm.
I look forward to meeting you after.
Dr. Williams, what's going on in your world at NC State?
I would have to say that one of the more exciting things that has emerged at NC State over, I would say, the last 10, 15-ish years has been the focus and emergence in interdisciplinary research. I think that it's hit many different facets and factors, and I think ag is one of those areas. And with that, I think that there's tremendous benefit in having institutional support for the growth of interdisciplinary research, interdisciplinary interactions in various research fields. And this, to a large extent, led to the emergence of the North Carolina Plant Sciences Initiative, which really serves as a connector between various colleges at the university, various departments at the university, to really push translational agricultural solutions for North Carolina stakeholders and beyond. And I think that this is where one of the more exciting aspects are, because we have the recognition as part of the PSI that we need those connections. We need to be able to, even in areas of fundamental research, look at fundamental research and the growth of fundamental research through the lens of translation. Because if we can help to put in place the mechanisms for that, we can connect fundamental research to the implementation of that research, to the extension network, all underpinned by establishing a strong workforce development, which is going to be key for not only stakeholders, but industry as well, but also underpinned by what we've been talking about this whole session, which is how do you incorporate in an effective way data and data science into these ag problems. And I think that that in itself, to me, is one of the most exciting things, because it really transforms how we think about research. It transforms how we think about the delivery of research. It transforms who's involved in those particular research problems. And the hope is that that will lead to more effective solutions.
You mentioned workforce development. Let's stay on that topic. We had several questions from the audience on workforce development, and as we were preparing, we knew that we wanted to talk about career paths, careers, overall opportunities. So let me summarize, because there were 3 questions from the audience. How can we attract and retain data scientists in ag rather than other disciplines, right? There is a big wide world out there of people doing, and it's not just data and ag. How do we get, rural farm-based people into data science, as the number of people with ag experience declines? How do we ensure that this real world experience is not forgotten? And so those are all topics on the minds of the audience. I guess, John, I'll start with you on that, because I know a little bit about your background. And so I wonder if you might kick off sort of a workforce careers discussion for the panel, and tell us a little bit about how you came into it, but also let's make sure that we figure out how can we get more people in data science and ag. What's the answer to that question?
Yeah, if you would have told me 3 years ago that I would be sitting on a panel of distinguished agricultural experts talking about data science at NC Biotech, I would have said you were crazy. I haven't been doing this my whole career, yet I'm consulting, as you mentioned, Andy, into some of the largest ag digital transformations. And so, how did I go from 0 to conversant or proficient in several years' time? So first of all, I had a motivating experience, right? And I can't understate the importance of having a strong motivation to do that. Because you know what, math is hard, statistics is hard, machine learning is even harder than statistics. And so there has to be a very strong will to push through the hard math and get that done. The second thing is I had a mentorship or a mentor, and it was someone who was able to coach me and patiently teach me things and really connect the business value of data and of particularly mixed models to what we were doing in our business. And that only came after the motivation, right? And it goes with the saying that when the student is ready, the teacher will appear. So motivation, mentorship, and then the third thing that wasn't necessary, but I think accelerated my journey, is the access to no code, low code analytics. So that's the big trend in data science, and that is the means by which we have discovered to give practitioners access to data science tools without imposing the barrier of learning a coding language. Right, and props to those of us who are learning coding languages, and that is a great way to see how algorithms can process and change data, and that's a wonderful way to learn. But for me, coming from a qualitative practitioner's background, the ability to query the data with models, Bayesian models, neural networks, generalized linear models, and see what that did to the data, see what that does to the residuals. That was a way for me to answer questions on the fly and learn about my data. But little did I know I was learning about models and modeling itself.
How do we get more people in data science and ag, Dr. Williams?
So I think I can address that question from a more anecdotal standpoint. I think oftentimes people believe that you have individuals in, let's say, engineering as a whole, that ag and agricultural problems would not resonate with them. And that's not the case, especially now. I think more and more individuals are focused, especially in engineering, are focused on how they can utilize the tools that they know to address really complex issues and problems. And what I mean by anecdotally, when I started as a faculty member back in 2008, there was one faculty member working in the ag sector. And that's when I started, that was me. If you look at the number of faculty now in electrical engineering working in the ag domain, it's up to about 5 or 6. And this is just in electrical engineering. If you look at the plant sciences building, which is essentially the building and the infrastructure for the plant sciences initiative, 25% of the programs within that building are from the College of Engineering. So there is an interest there. And I think that exposure is key. Having individuals, providing pipelines for having individuals across these different disciplines to have the ability to understand and appreciate the types of problems, I think is also key. And this is only, of course, one of the many possible solutions, but that's going to foster the development of interdisciplinary, cross-trained students. And it's those interdisciplinary cross-trained students that are going to be those ones that are going to populate that workforce pipeline. Mm-hmm. So personally, I think that the potential solution is going to be to continue to try to build these types of large interdisciplinary groups and incorporate under this umbrella these different disciplines that are needed to address these problems. Because the students are there. The students have interest. All of my students, going back from when I started, they came to me, I told them what they were working on. So, okay, well, you got to take biochemistry, you need to take genomics, you need to take all of these other biology courses. And most people thought that they wouldn't want to. They said, yeah, this is great. All right, you know, for me to understand this problem, I'll go through that initial quote unquote headache to be able to understand how I can utilize what I'm doing to solve that problem. So the people are there, the interest is there. I think just making sure that we establish that pipeline and an environment for them to actually enable and conduct this research, I think that's the key to helping to build out that pipeline.
Dr. Goins, do you agree, or do you have?
I do, absolutely. Matter of fact, while Curliss was talking.
The panel's better if you disagree.
Oh, okay.
No, I'm just, go ahead.
I'm having a bad night, y'all.
No, I'm just.
So I was thinking about how I hated philosophy at UNC Chapel Hill. I was like, why did I take this? But then it just came out, I needed it because Socrates said, you know, who's teaching our children and what are we teaching them? And that's key. And so the education system at most universities, you know, they don't tell you that biology is based on chemistry, chemistry is based on physics, and physics is based on mathematics. And so the tyranny of the credit hour keeps these disciplines apart. And maybe even the political machinations of the structures of the deans and everything, you know. And so that's the issue, is that these youngsters that Curliss was talking about, they don't see math, chemistry, biology, and physics necessarily separated. But fortunately, we have interpreted languages now like Python and MATLAB, where you don't need to know who Runge Kutta was if you're a biologist. You just need to understand that there's some tools out there and some interpreted code with all the little colors and stuff, and tells you when you have an error, and you can call up somebody at midnight and find out what the syntax error is. So it's a very good time once we get our kids in that right track, that they can get past some of those tyranny of the credit hours, how our education system is structured right now. So that's the way I see it.
Mm-hmm.
I would say, I think Dr. Williams, you kind of hit on it. To me, people stereotype agriculture. Agriculture, no, I want to go into engineering or be a doctor or be a lawyer. You know, I see it all the time. I married my wife's from Charlotte, nothing wrong with Charlotte. But when she came to Eastern North Carolina, it was, what is tobacco? They cure tobacco in a barn? Yeah, sure they did. So I think the first thing is making sure folks like myself, the younger generation, is engaged in agriculture, and we actually understand the opportunity at the ground level. If you take a lot of younger generation on the farm, they get to see the technology, the equipment, and all of a sudden, a whole lot smarter guys than me, like you guys, will say, wow, look at all the opportunity to do artificial technology, to do more data science to help this farmer, family farm. Maybe I engage and I get motivated because I want to help that family farm spin in business for 50 years, sustain for the next 50 years. So I think it's really helping the younger generation understand the opportunities out there and get the stereotype out of there, because there's a lot of avenues, that's for sure.
Here's a question from the audience. In 5 years, can we expect that all major tech players will have an ag division?
So I would like to jump at that one.
Yeah.
Just coming from the ag retail sector, and selling chemicals and fertilizer, everybody
What
wants
does
to
that
get.
mean, ag retail, for folks who don't?
Oh, I'm
know?
sorry.
That's an industry phrase that some may not understand. What does ag retail mean?
So ag retail, we sell seed, chemical, fertilizer, any inputs a farmer needs, we sell those to help them raise their crop.
Hmm.
And it has been really interesting to see somebody like Bayer, develop Climate, right? Massive, big conglomerate, throwing a lot of money at it. And it's been interesting to watch Bayer, Syngenta, Valent, some of these other players want to jump in the tech space. And I think the biggest thing that they realized very quickly, it's really expensive to play. A lot of platforms don't collaborate with each other because Bayer wants just to talk to Bayer, Syngenta just to Syngenta, and so forth. And I think the reason why they're trying to get in that space at times is because selling glyphosate, you mentioned, is not very profitable. And there's not a lot of novel chemistries on the market. So to answer the question directly, I'd say we're going to see more and more big companies get into tech because, it is sexy to a certain degree and it can be profitable, but it seems to be short-lived at times, at least from my perspective.
Interesting. Anybody else want to chime in on that? But you don't have to.
Well, what they asked Willie Sutton, why does he rob banks? And you know the answer to that, right? If there is financial reward there, absolutely.
Mm-hmm.
By the way, he said that why do he rob banks? Because that's where the money is. That's the driver, even for our campus. Now when we have grant competitions normally, the people in my college from the agricultural college would apply for the grant, but sometimes now we have to compete, which is a good thing. Competition is good with people from engineering. I have colleagues, I want to submit that grant. Often we have to either, which is a good thing, we got to collaborate or even compete, and hopefully we collaborate. So it's not even businesses at the universities now across. Then there's the social side of it, with this whole thing with, like I said, health and, depending on some of the environmental issues, the sociology departments are involved now. So it's been rediscovered. And then lastly, but not least, COVID put a focus on a lot of areas where people and industries are interested where the food comes from. So if there's anything good come out of COVID, that was one of it. There's more focus on the origin of the food, calories.
And I think it is interesting that some of these tech companies, one of the plays also is if I've got a new fungicide that's going to launch in the soybean market and I'm helping analyze yield through a platform that I've created through tech, guess where my price point is going to be? If I know that I can consistently get 20 bushels per acre, I'm going to recoup that through my price point. Another reason to get into tech as they price their chemistries into the marketplace as well as seed.
Yeah, you mentioned COVID and the food system. Our friend Ray Starling had a real nice comment on that the other day, that it really didn't expose that the food system was broken, which is part of the narrative. It exposed that we all eat at restaurants. And when the restaurants all closed, we all had to figure out how to go get our food somewhere else. And we did that pretty quick because some of us put on 15 pounds, right? The COVID-15. So food system not broken. It was just where you got your food was different. Let's talk about the data. We had an audience question, and we had wanted to talk about this as well, which is the data itself, ownership of data, sharing of data. We've touched on that. Trust in the data. We've touched on that. All of these things are concerns. I guess the question is, what's the path forward as it gets to those silos, those ownership questions, and fundamentally, how do we solve the issue of who owns the data, and then who can thus work with the data, and then certainly produce insights and decisions from the data. How do we solve this issue that keeps coming up but doesn't always have a clean solution? Who wants to start with that? Dr. Williams.
I think, at least from my perspective, I think it's clear that the solution is complex, if a solution exists. But I see two major components associated with the problem. there's, a societal aspect, and then there's a technical aspect. The societal aspect is, whether there are clear incentives for how this information can be used and whether there is reciprocal value for the stakeholder that's providing the data, whether there is a community of sharing, whether there are certain communities upon which data could or should be shared, and certain communities outside of which people are not comfortable with. Being able to establish those policies, I think, is going to be key to the societal or social aspect. I think there's also an opportunity on the technical side where you start looking at algorithms, for example, that literally shield and or encode the information before it's even used, such that you never have to see the original data. You can actually use just an encrypted form of the data and integrate that into machine learning or AI approaches. And this is where there's opportunity in terms of developing the types of algorithms that would be needed on the computer science side to be able to do that. Because one of the limitations in doing so isn't whether or not it can be done, it's the time that it takes to do it. It's the time that it takes to decode and make sure that everything is shielded and only held within the algorithm. So I think that there's opportunity on both sides. I think that especially when you start to incorporate the side of computer science, et cetera, there's opportunity for new types of approaches, new types of algorithms that would help to, at least in part, address aspects of the privacy issue. But I agree that it's definitely a complex problem. But I think that there are avenues, hopefully, that we can make some sort of headway in terms of a solution.
I hate to mention politics again, but it's going to come to a point where we have another Craig Venter situation. The brilliant person, but he wanted to when he cloned, he was shotgun sequencing. He was going to beat the punch to Francis Collins and the government sequencing, and he was going to own the human genome. So, but it took political will. I think Bill Clinton was the president and pulled it together and put them together to work this out so that it wouldn't be owned by one entity. So in my opinion, eventually it's going to come to that where there's got to be some from the will of the people to put the people in power to be able to solve this issue. Because it would be a shame if the data is owned by one large Bayer and things like that. So that's the way I see it, kind of that same model.
Yeah, I mean, at the end of the day, everybody's territorial. So if you've invented a novel chemistry and you're with any of the big chemical companies, you probably don't want to share that trade secret with somebody else. And it's no different than, growers who have found a way to raise 300 bushel corn. I don't want to share it with you because you're my neighbor and I don't want you to buy a farm that comes up for sale 20 miles down the road. So I think the biggest thing is, answering the question of why, and can we all get on the same page, politics or not, of, hey, this is good for everybody. And can we buy into that? And that seems to be hard to do in today's age, but that's what's going to have to happen, which is tough.
John.
And I'd flip the script a little bit. Often when we talk about data sharing, data privacy, trust in data, we think of 10,000 acres of corn and soybeans and how's Deere interoperable with Bayer, interoperable with someone else. And I think those are all valid questions, and there are different approaches in the ag industry to address them. I'd like to address it from the point of someone learning data science needs a data set to work with. And there are public repositories online like Data Dryad or Google Datasets where you can go and pull a data set, Kaggle competitions where people upload data. And coming from academia, there was always talk about, bemoaning why don't we publish failed research? Why is our system not allowing that? And to me, the perfect solution is go ahead and slap up your data set on one of these sharing websites. And guess what? A couple of years down the line, someone from across the world will download that data set and try to solve your problem. And so just making available test data sets for those of us who are entering data science and learning data science techniques to probe and to query. That's going to expose a whole new set of eyes to the problem and potentially work out the failed research while training the next generation of ag data scientists.
At the end of the day, in a lab, when you make a discovery, the first words that come out of your mouth is, "That's strange." You know, and so that's I thought about that.
Not eureka.
Yeah, right. That's it. And so, you know, so-called failed data might not be failed at all.
That's exactly
Somebody
right.
just view it as strange, right?
Mhm.
I think there's this general sense out there that the farmer especially is hesitant to have other people in control of her data or his data. That there's down to the farm level, it gets to be really ornery. Is that your experience? Or are we talking more about these siloed trying to monetize, you know, ecosystems as we've talked about in the vertically integrated or the larger agribusiness space? Where really is the friction point there? I wonder if you might respond to that comment.
Yeah, you know, Bayer, again, on their climate, they've got an opportunity when the grower utilizes that platform, the grower can share the data back to ag retailers. And the point in that is so the ag retailer can analyze the data to help him make better decisions.
Mm-hmm.
But I bet out of the growers, maybe 20% share their data.
Mm-hmm.
It's just something that they're not willing to do. And I hate to beat a dead horse, but I truly.
That's okay, you can beat the dead horse, yeah.
Today I can, since I'm on the stage, I guess.
Yeah.
But you know, I truly think it comes back to that growers are so competitive, and there's such a competitive landscape out there that, and just to really break it down, maybe too granular, is that when you look at basic row crop farmers of corn, cotton, soybeans, you know, they may be paying land rent of $100 an acre. And then their neighbor beside them grows corn, cotton, soybeans, and tobacco and sweet potatoes. And that big sweet potato grower will go and he'll pay $300 an acre for that piece of dirt on a 3-year contract. And so when I know that, it's hard for me to share trade secrets and therefore share my data and production practices.
Yeah, I think that's really important, and that gets lost in the data sharing conversation. Is it's a business and there is a competitive factor, and you don't go, you know, Wendy's doesn't share with Burger King other than what they have to, right, in the public markets. And when you're not a publicly traded company, you don't have to share your information with the world. And when you share your data, that's what you're doing. And so working through that is, I think we've all said, is a challenge. Yeah, go ahead.
I think one of the weirdest things that we saw in conducting some of our research was when we put that same question to a set of growers in North Carolina, they were more hesitant to share information, to share data with growers outside of the state than they were with growers inside of the state. So if it was an approach that would help to raise the status of that particular field or that particular crop in North Carolina, they were more inclined to share that information across North Carolina growers, as long as it didn't get out of North Carolina and as long as it didn't leave the US. And that raises to me a subtle level of complexity in terms of where people see the value, because they saw value in raising the economy of North Carolina as it related to that crop, and was more hesitant because they didn't want their competitiveness to leave this state. So I don't know how we address that across the diverse sets of crops that's, you know, in existence or within North Carolina, but I do think that there is a level of complexity associated with those dynamics.
And some of that complexity is we have to be careful of when we say the word farmer. There's a continuum based on knowledge and willing to take on risk. If you're looking at innovation and using data, like we say, we have those standard row crop growers that are inherited the equipment. They're well connected. They perhaps own the land or at least renting nearby land. But then you have the younger generation who want to change the direction of the farm, whether it's poultry, they want to maybe change to something else. You know, what are we going to do to where they can maintain, they want to maintain the land, but they don't want to be stuck in a vertically integrated system. So that's a change, because most farmers now 50, 60, 70 years old. So that's something that's, hopefully the data science has something to say about that. And then lastly, we have our returning veterans or someone that's returning back to the land where they have little investment in equipment, and they're willing to innovate. They're willing to do everything we're talking about, but they lack that knowledge and connection to the system. So it's a two-way issue. So I just want to just caution the audience that when you say farmer, you know, maybe dig just a little bit deep what type of farmer you're talking about. We have all of those in North Carolina.
Well, and we do have a question from the audience. Why do we perceive that the farmer data should be shared when big business does not? Right? Who would pay them for this open access? As a question, I don't know if anybody wants to respond to that. And there was a related question, which is, what is the impact of data on property values? That also gets it right down to the farm level. Not always a farmer, but so I wonder if you might react to either of those, which is just a continuation of this discussion. But you know, maybe there's a way to monetize it on the farmer side, is a thought. And what is the impact of data on the property value? Certainly, Wes, you've talked about that. There are some other, I don't know how much you guys have focused on carbon. And certainly we all know the capture of carbon is important right now, and trying to incorporate that into property values. That would be a data-driven exercise. I wonder if you have thoughts on that. What's the impact of data on property values in this sense?
So for one, I agree with whoever said, why should we share our data? Because other businesses don't do that. Now, how can big chemical and seed companies monetize it? That's pretty straightforward in the sense of the bigger data set they can get for certain corn hybrids, cotton varieties, et cetera. They know how to place that variety better on certain soil types. Keep in mind, in North Carolina, you may walk across the field and have 5 different soil types. So if a seed company can place it better, the grower places it properly, higher yields, he's going to buy that seed again. So that would be the thought there. And then as far as, you know, land prices being higher, I think I saw a farm in Iowa that was $30,000 an acre. And how did that get that high in value? It wasn't because there was a oceanfront view, right? It's because you can grow consistently 280 bushel corn year in, year out. So guys understand that they're willing to pay that. So.
And then it boils down to, if you're North Carolina has what type of soils? Poor soils. Okay, generally. Okay. I know, maybe y'all gonna strike that out of the recording. I don't know. But especially Eastern North Carolina with the Norfolk sandy loam soil, which is conducive to tobacco growth. And so you have to make up those amendments, nitrogen and phosphorus particularly, because of low cation exchange capacity. So the thing that can increase the data was if you can show the fertility. And I look for one day when we don't have to dig up some dirt in a plastic bucket, put it in a box, and take it to Blue Ridge Road. You know, one day it'd be nice to get all that diagnostic right there at the farm. And the more that we become smarter with more tools that we know exactly and map that soil survey, knowing what our land is, rather than just guessing and waiting for the results to come back, that definitely will increase land values. We know more about what's in that land as far as fertility.
And I would add that where I've seen a lot of progress in sharing data and growers willing to share data is in the horticulture sector. So, you know, greenhouse growing, greenhouse production, for example, and not necessarily sharing data with the public at large, but sharing data with the industry that is serving them. And you know, it's really for the main reason is that horticultural operations are intensely focused on product quality. And every little bit that they can do to improve product quality, increase the number of bins that are grade A, for example, that is a big result in their bottom line. And so they're willing to share their data to have someone help them. The companies that I've seen do this very successfully are the ones that first of all, integrate an automation component. And so they open up the glass house vents or they move the tables or do something that actually can decrease the labor cost and improve quality. The second one is the personalization of the result. So being able to see in an app how this is working for you and fitting with your operation. And then the third one is at least the perception that, hey, I'm sharing data with the seed company, they're in my greenhouse now, but they're helping me optimize my outcomes by recommending the seed that is right for me, right? It's like the cookie question where it's like, hey, would you like us to personalize ads to you, right? Rather than do you want to share your data with us? It's the framing of the question, it's the framing of the value. So certainly in horticulture, we've come a long way in sharing data between companies and producers.
I'm watching the clock and I'm sure Michelle's over there getting nervous. I think there's time for about one more question, then maybe we'll open it up for any further audience questions. And then I don't know if we have cookies. John's mentioning cookies. Maybe we'll have some cookies. So let me end with, we've heard about challenges. So I wanted to ask this question about, of those challenges, if you could wave a wand and resolve one of these, that it would make a difference, what would that be? But so I plant that as a seed of a thought, and I want to make sure that our audience question comes in because it's in the same territory, which is really just a crystal ball question, which is, in what ways will data science transform agriculture in the future? Was the question here. And I think those concepts are related. It's the idea of, man, if we could overcome some of these challenges, let's wave a wand. What would it be? Where's the main area that you would like to see some attention to make a difference and to transform agriculture? How would you answer that one? John, I'll start with you.
Sure. So having been through a transformation to go from 0 to at least functioning on a data science team myself, I love to spread the message to other people who may not see themselves as data scientists or data driven, right? In college, my attitude was, I had a statistician talk down to me once, and that was the end of statistics, and that was the end of ever talking to a statistician. And I resolved then that I'm going to make a friend who's a statistician, throw my data over to them, have them do the statistics so I can get out the publications, right? But then I had a very visceral experience in industry where it brought home to me the importance of actually learning this stuff and actually being a participant and having a seat at the table where data is at play. And so what I do and what I sort of pride myself on doing now is spreading the message that yes, you can do data science too. And yes, you can build your career around data science. And no matter how big or small the company or the team that you work in is, you can integrate elements on that team to improve the value of yourself and the value that your team is bringing to the company in very short order. And so, being able to mentor people at really any stage of their careers to show them the power of data in your hands is something that I certainly like to do, and hopefully it's made a difference in a few people's lives.
Thank you, Chris. And what wave a wand, but how would you transform ag with data science? What ways would you do that?
I would say the ability to establish an interdisciplinary framework in research, education, and extension that lowers the barrier of entry of technologies and is able to provide translational solutions across farm scales. If you are able to establish that initial fundamental framework for interaction, for interdisciplinary work, for establishing a pipeline for facilitating that information to the growers specifically, or establishing a mechanism for having early integration of their value, their perspectives into the solution, and being able to funnel that solution in a way that does not make those technologies prohibitive. That would be the magic wand. And that would enable the ability to produce various types of solutions for a wide array of individuals. And I think if we can focus on trying to do that, I think there could be significant impact across the board. Now, where that solution lies or how that would be done, I don't know. But I think establishing mechanisms for that framework would be key.
Excellent. Dr. Goins?
You know, North Carolina has been really good to me. So, you know, UNC Chapel took me in with probably affirmative action, you know, my SAT. And so NC State, Johnny Wynn took me in crop science. So I talk real about our soils in North Carolina, but I want you to know it's a love of North Carolina. I tell you the truth and the way I see it being an agriculturalist. But having said that, for North Carolina, if I could, for data science, I hope it can somehow lower the distance between the have and have-nots, where you can look at only a few counties where all the wealth is you know, and the growth is stationed. What is it, about 4 or 5 counties? It's not many, where what, 50, 60% of the wealth of the state. And I hope that data science and ag can help bring back the Fairmont, North Carolinas, the Whiteville, North Carolinas, that was based on the golden leaf. You know, we've been looking at emus and CBD oil and things like that, but you know, so the data science can have it where these farmers just don't go out on a limb thinking they're going to replace the golden leaf, but have a decision-making way to can bring back these communities to have equity across our beloved state. Thank you.
Yeah, I think I agree with everybody. You know, data science is going to transform agriculture because, you know, it's going to consolidate growers. You know, the grower who says, I'm going to outwork somebody, I'm going to work with my back. Every day I'm gonna work longer and harder, that just doesn't work. So it'll transform it through consolidation. I believe that for sure. And what these guys hit on is, you know, data science, you know, answering the question of why. Why should, I'm a 5,000 acre grower, 1,000 acre grower, 10,000 acre grower, why should I do this? To make higher yields. Okay, great. Where do I start? I mean, really, if any of you in this room went down to the granular level of the farmer, which I'm sure you do at times, and you said, hey, let's get into data science on this farm. And he's fully engaged. And he says, you know what, I want to make big yields. I've got a son, now a grandson, what have you. You know, where do you tell him to start? You know, is it going to buy the technology? Hey, I've got plenty of money. Great. I'm about the technology. Then what? And then what decision do we base it off of? Now that we have this, we do this. And I think it goes back to Dr. Williams. You hit on this a lot, the translation, right? From the extension agent to the retail to the grower. There's a lot of disconnects here, unfortunately. So,
well, I think one thing, if I could comment on that, you heard Wes say, I don't know, a dozen times in this, the decision, and we talk a lot about that. All of us have that. There's a lot of data that produces information, and information is great, and we all love a good-looking dashboard, but it's really meaningless until you get to the point of what's my decision that I'm going to make. And I hope that came through loud and clear. When you think about data science and ag, it's really about what decision am I going to make in ag? And I use the data science for that. I hope that has come through loud and clear in this panel today. I think before we do so, we're going to ask for some questions. We have about 5 minutes. Is that right? But before we do that, I wouldn't mind just a round of applause for our panelists. Thank you. And if you have a question, Michelle has a microphone. Comment.
Afterwards, you have to run the microphone. I just want to say to Wes that I really appreciate you being here today and bringing your perspective. Quite often, I think we lack that grower perspective when we have these discussions, and it is so important. And I'd just like to also think, I think the panel has highlighted the fact that growers at the farm level process data, analyze it, and make decisions hundreds of times every day. And really what we're talking about is that we're just trying to put that process into a system where it can be tracked and the data can be used historically, because it's always happened at the farm level. So thank you very much, Wes.
Thank you.
So I was listening to the discussion about how far back we started with data management, and you mentioned Excel, and I was thinking, I remember like a black and green screen with somebody punching it in, and then you run it, and it's like these printers on campus at Arkansas that we had to drive down to pick up the printout. And then Lotus 1, 2, 3 came along, and that was great. And then, so all these things kind of, there's a lot of that. But what kind of came to mind was, what is the lifespan? We're talking about data for climate change, for example, for climate. Well, that has to be, that's a long-term thing. We have to be able to get to that data. And I suspect that most of that data that we punched into all those 5.5 or whatever they were, the floppy drives, I would doubt that there's a program now that even runs through that can read it. Am I right? So if you're going to have long-term data sets, one is they have to evolve such that these programs can go back and read that. So that leads me to my question is, what is the lifespan on the things that are being developed now for our producers? One of the things I feel like that our producers step back from is, we've got a $150,000 planter, and we're going to put a card in it, or we're going to put something in the tractor to read that, and we're going to plant 3 varieties or hybrids in one field, and that's great. But how long till we need a new planter with a new computer system, and it costs it costs $250,000 now. And those are the kinds of things it's not that farmers are averse to change and technology, but they understand that this is not a 3 or 5 year problem. This is a lifelong, and I've got kids that are coming into it too. So if you were looking at it, I need to make up a question here. So if you were looking at it, can you put this together to where it's a long-term solution or to problems that can evolve as all that evolves with it? So it's not just we're going to buy a $150 planter and that's going to solve this for how long? It's going to last for a few years. So that's it.
So I would say that it's a great question. And I think the biggest question is, hey, John Deere, when are you going to stop, coming out with the Gen 4, the Gen 5 monitor, because I can only afford the Gen 4 and I got my whole system set up around that. And I think another, good point is, these corn hybrids or cotton varieties, soybean varieties, they're good for maybe 2 to 4 years. And I kind of got my data based around that certain hybrid that fits here. Well, now here's the latest and greatest, and I'm making production decisions basis that. So that's a good question. I don't know the answer, because I think the turnover in technology, as we all know, whatever space we're in, continues to get greater and greater. Any other silver bullets?
I mean, I think it comes down to one of the things that we didn't talk about was standards. So the establishment of data standards, or the need for establishment of data standards. It also comes down to the culture of that specific area and or field. So in the computer science realm, the idea of having code that has the ability or has legacy capability is key, especially in the open source realm. So the question is whether or not this area of tech and data science and ag is going to adapt a similar type of approach. And I don't know. But I think establishing a community of individuals that push for not only those types of standards, but push for that level of connection across what's being done, I think is going to be important. How that interplays with other industrial factors in terms of your Bayers and other companies that, clearly their incentive is to have things a certain way. I think those are conflicting positions. But I think for the longevity of identifying solutions, moving towards standards and an openness in terms of the analyses is going to be important.
And what I would say as a data science practitioner is, when it comes to cotton varieties, for example, there are ways to break down varieties into their quantitative components. Number of bolls, number of fruiting branch bolls, length, micronair, that type of thing. And by breaking down varieties into their continuous components, a lot of data scientists call it reaction norms, that allows you to extrapolate from one variety to even a future variety. And so between that and hierarchical data modeling, we have some tools in our hands in agriculture to deal with some of the categories that we have. The other thing I would add is that in agriculture, we have some of the richest experimental data out of any biological field. And I always like to say it's because we have an unlimited number of patients, and it's okay that we can kill them, right? So being able to incorporate all of this rich experimental data that is in general well curated, multiple eyes on that data set is really a competitive advantage that we have as data scientists working in ag.
And in the United States. There's I forget what the question was, but I had a thought that was, as you were asking it, that there is a piece of this that is right before our eyes, which is the American land grant system that nowhere else in the world does what we have exist. And so that should leave us all feeling optimistic about how the next gains and efficiencies will come. Part of it is just that system that we have in place to make sure that America is secure in its food.
And that relates to enablement, and that's what turns our competitive advantage into, I believe, an absolute advantage for our industry.
Question.
So there's a very good point you made about this interoperability, and I heard John Deere, etc. So there are two standardization activities going on where they're trying to look for where standards are. And one is the smart farming at International Standards Organization. That's coming to a close. The other one is one at IEC, which is the International Electrochemical Consortium, which is like ISO for chemical. And I have been trying to get, I'm actually leading a working group on biodigital conversion in agriculture. I cannot get people interested in standards because I think they all want to be Apple and they don't want to be Gateway or Dell or anybody else. And they don't want to share it. They don't want to share the standards because, as somebody said, Bayer wants to be the key and they want to keep it themselves. So the question is, how do we move towards that? And then the other point about data is, how do we encourage people to collect more data than they need? Because in 5 years' time, we'll want that metadata that was not collected today. So there's really two questions. Well, there's maybe one encouragement to get involved, and the other one is, how do we get all that metadata that we will want in 5 years from now, that we don't know we need or we want? Thank you.
I have no answer for the first.
Mm-hmm.
That's a tough one. That's a very tough question. I don't know. It's clear that there's going to have to be many facets that are associated with those types of solutions. Again, whether it's something that's going to be pushed by the data owners themselves, whether it's something that is going to be more top-down, like Greg said earlier, in terms of policy, or whether it's something that comes out of the natural market. I have no idea, but it is a need, because if you do want to have that level of longevity, that's going to be mandatory, necessary. And the second question was?
Metadata that's not being collected today, but will be important in 5 years.
Yes. So I think that goes to the data management strategies. So having the ability to not only collect information, collect data, but also collect metadata along the way becomes extremely important. This is something that we typically have issues even in controlled experiments. There are no readily active solutions necessarily across large scale projects and experiments to do things like that. We are just adapting those types of frameworks for the types of research projects that we're working on. That is a need, that is a gap. And then figuring out how to encourage individuals to actually do that and collect that information is also going to be a significant hurdle. We have trouble trying to do that for researchers on a project where they know they're supposed to do it. So that is a problem. That is a problem. And I think establishing the framework, which is some of the things that we've kind of done for research projects, and then enabling the mechanisms for facilitating the collection of that information. We know it's a need. I think there are solutions, but I think being able to convey that as we have these types of discussions becomes extremely important.
Part of my job is to watch the clock. I'll give Paul the last question.
Well, mine really is kind of a closing comment as well. It was more the confidence that today's panel, Andy and the whole panel, thank you. Just last week, we held a program focused on bringing investors into the state. The theme was crop science. And Adrian and his team did an awesome job hosting. So Andy, John, and Carrie are going to be hosting the similar program we're going to do at SAS. The theme in the back of our mind was ag data science. And I want to thank you four gentlemen because you really kind of brought to light the thought leadership we have in the state related to the topic. I think North Carolina can really be a leader in the area of ag data science. He also brought up a lot of challenges facing the space in really making sure the data science field is really advancing agriculture forward. And we really want to bring, attract the best and brightest investors in the space. That's kind of the reason for the program. So I just wanted to thank the panel. I think you really hit on a topic. And I think North Carolina is really going to be leading the space. So thanks, gentlemen.
That's great. And I would ask the panel to remain, and I'll invite Michelle back to the stage.
I know we're running a little over, so I thank you for your patience, and you guys have just been so engaging. We can't help ourselves. We just keep asking you questions. So I want to thank each of you, and I want to thank Andy, and I also want to thank Carrie Harbinson from SAS, who really helped behind the scenes in coordinating this program today. And it's that time of the year, gratitude. So I want, on behalf of North Carolina Biotechnology Center, want to express our gratitude and appreciation for such an amazing ag tech community in North Carolina and making us what we are. And as Paul said, data science and ag is a big subsector that we are really starting to focus a lot more on. And so we really appreciate you guys helping to lead that charge. So it is time. We have reception outside. I want to thank our sponsors again, HPG, who is not here, but they are in spirit, and Smith Anderson, Myers Beagle, and Alexandria. So happy holidays.